In this video, we are going to start to learn microservices observability with distributed logging and distributed tracing. So microservices architecture have become the new model for building modern cloud native applications, and microservice based applications are distributed systems. So how do you handle the complexity that becomes the cloud and microservices in distributed architectures? One of the best way to understand this complexity and manage this complexity is using the microservice observability, and microservices should have a strategy for monitoring and managing the complex dependencies on microservices. That means we need to implement microservices observability with using distributed logging features, distributed logging and tracing features. Microservices observability gives us greater operational insight and leading to understand incidents on our microservice architecture. Microservice observability refers to ability to monitor and understand the behavior and the performance of a system made up of the microservices. Distributed logging and distributed tracing are two key tools that can be used to improve observability in a microservice applications. Distributed logging is a practice of collecting, storing, and analyzing log data from multiple service instances in a microservice architecture. This can be useful for understanding the behavior of the system over time and identifying patterns and trends and troubleshooting the issues. Distributed tracing refers to practice of tracking the flow of the request through a microservice architecture in order to understand how the different service instances interact with each other. This can be useful for understanding the performance of the system and identifying bottlenecks and troubleshooting the issues. So here you can see the real world example how distributed logging and distributed tracing might be used in a microservice architecture. Imagine an e-commerce application with multiple microservice instances for managing the shopping cart, handling the payment process, and managing the product catalog and so on. So in order to improve microservice observability, the platform might implement distributed logging to collect and store and analyze the log data from each of these microservice instances. This could include the information about the service calls, errors, performance metrics, and other relevant data. The e-commerce application might also implement distributed tracing to track the flow of the request through the system. For example, if a user adds an item into the shopping cart, the trace might include information about the request flows from the shopping cart service to the payment processing service to the product catalog service and back. So distributed logging and distributed tracing can be useful tools for improving microservice observability and understanding the behavior of the microservice architecture in real time. So you can see the image on the slide that representing e-commerce application allowing the observability with providing distributed logging and tracing features. Every microservices logging in the central logging microservices and aggregate the logs in the different microservices, and these microservices will be represent the log and identify the troubleshooting issues and metrics. And at the same time, the distributed tracing can be applied through a use case flow. For example, when a client application is triggered to add item into shopping cart use case, this will be triggered to downstream shopping cart microservices, and this service could be the go to payment and ordering and respond back to the client application. During this process, we can use correlation ID or trace ID to identify which step got exception from this throw of the flow, request of the flow. In this case, for example, payment could be done. We can easily identify the payment microservice is done with following the correlation ID and the request of the flow. So this is the power of distributed logging and distributed tracing features.